representation of organic compounds. So the organic compounds can be represented in different manner. One of the simplest method is Lewis structure. The simplest method of representing organic molecule is Lewis structure. The Lewis structure of representation of organic molecule can also be called as dot structure. Lewis structure or dot structure. So in the dot structure means here the shared pair of electrons are represented by dots. So this is the very important thing here. So we studied organic compound means covalent compounds of carbon. The covalent bond, that is the shared pair of electrons, are represented in dots. That is why that structure is called dot structure. So or it is otherwise called Lewis structure. Example. So if we take methane, we know this is the formula for methane, CH4. So carbon is there. Carbon make a covalent bond with one hydrogen this side, another hydrogen, another hydrogen, another hydrogen. For covalent bonding we need two electrons. One is shared by carbon, another one is shared by hydrogen. These two electrons are represented by dots. Therefore, this structure is called dot structure or Lewis structure. This structure is called dot structure or Lewis structure. This dot structure or Lewis structure can further be simplified by representing two electron covalent bond by dash. So in dot structure we studied the covalent bond is represented by two dots. It is further simplified by connecting these two dots and make it as a dash. Such a structure is called dash structure. Such a structure is called dash structure. We studied methane having this is the electron dot structure of methane or Lewis structure of methane. This structure is further simplified by connecting these two dots as a single dash. So this type of structure is called dash structure. So the dash structure as well as dot structure or Lewis structure, they mainly focus on the electrons involved in bonding. They mainly focused on the electrons involved in the dash structure. A single dash represents single bond. A double dash represents double bond. A triple dash represents a triple bond. Example, ethene can be represented as, so this is one carbon atom. So here single bond with the hydrogen, double bond, carbon, hydrogen. So this is the formula for ethene. This type of representation of organic compound is called dash structure. It is called dash structure. One more example for dash structure, propan-1-ol. So here first carbon atom having 3 hydrogen atom. So this joined with another one carbon atom with 2. Here another one carbon atom with 2 hydrogen atom, OH. So 1, 2, 3 carbon atoms. So it is a propane, propan. OH group is there for propanol. So this structure is called dash structure. This dash structure is otherwise called complete structural formula of an organic compound. So the dash representation is also called complete formula of an organic compound. So far we studied organic compound can be represented in the form of Lewis dot structure or dash structure. Dash structure is otherwise called complete structural formula or complete structure. The complete structure can further be simplified by omitting some or all the bond present in it. So for simplifying complete structure, we are either omitting all the bond or some bond. And also in the simplified form of complete structure, we are representing same type of group together. For example, if 3 hydrogen atom is present, simply we have to write height as a subscript, we have to write 3. So that indicate it consists of 3 hydrogen atom. For example, this is the structure of propan 1-ol. Here 1 carbon is present, 3 hydrogen atom. So we are leaving 1, 2, 3. These 3 dashes we are leaving. So instead of writing this, we can write CH3. Simply we can write CH3. Now we are putting 1 bond here. So C, 2 hydrogen atom. So it can be written as CH2. This can be written as CH2 OH. So this structure is called condensed formula. This structure is called condensed formula. So complete structure can further be simplified by omitting some of the bond present in it, or omitting all the bond. The same formula we can write by omitting all the bonds CH3, CH2, CH2, OH. Without any bond also we can represent. Such a representation of organic compound is called condensed formula. It's called condensed formula. So the condensed formula, so we can write the atoms present together. That means here 1, 2, 3 carbon atoms. So C3. Hydrogen 3 plus 2 5, 5 plus 2 7, 7 plus 1 8, H8. Oh. This type of representation is called molecular formula. This is called molecular formula. Condensed formula of pentane. This is the condensed formula of pentane. The condensed formula can also be written like this. That is, we are writing CH3. Then CH2, CH2, CH2. 3 times, same type of CH2. So we are writing CH2 3 times CH3. This also we call it as condensed formula. The condensed formula can further be simplified simply by representing lines. That means we are leaving or we are omitting carbon and hydrogen also. See that CH3. So CH3 means that indicate terminal. All the terminals, the ends indicate CH3 group. Then 1, 2, 3 carbon atoms. So 1, 2, 3, 3 carbon atoms. Again end CH3. This type of representation is called bond line structure. This structure is called bond line structure. So in bond line structure, carbon and hydrogen atoms are not shown. We are not representing carbon and hydrogen atom. The line representing carbon-carbon bond are drawn in zigzag manner. They are drawn in zigzag manner. Atom other than carbon and hydrogen is present, we have to represent. For example, some of the alcohols contain oxygen, some compound contain nitrogen, some compound contain chlorine, bromine, etc. Such atom, that is atoms other than carbon and hydrogen, we have to represent. So in the bond line structure, we have to note down the terminals indicate CH3 group. Terminals indicate CH3 group. Like that, the corner point indicate carbon with a sufficient number of hydrogen. That means here carbon is present. This carbon having 1, 2 bonds are present. We know the valency of carbon is 4. There must be 4 bonds, but here only 2 bonds are present. So what about the other 2? Other 2s are hydrogen. That means in this position CH2 group is present. So the corner point represents carbon with a sufficient number of hydrogen. This type of representation is called bond line representation. Example for bond line representation. See this compound, the terminal CH3. Now this area CH2. This CH2 can be written here. This CH2, CH2, then again CH3. This is the bond line representation of this compound. 2-bromobutane. 2-bromobutane means, so butane, CH3, CH, CH2, CH3, butane, second carbon atom having bromine atom. So in the bond line structure, it can be written as, this is the represent, that is CH3, CH, Br, CH2, CH2. So terminal indicates CH3, terminal indicates CH3. The corner represent carbon with sufficient number of hydrogen. That means this carbon having 1, 2, 3 bonds are present. So we have to write CH. So CH. So this is the bond line representation of 2-bromobutane. Thus organic compound can be represented in different types of structure. Three-dimensional representation of organic molecule in a paper. So the three-dimensional structure of an organic compound are represented in two-dimensional paper by using this type of wedges. They are called wedge. So this structure is called wedge structure. So the three-dimensional molecule of an organic compound can be represented in two-dimensional paper by a special wedge structure. Two types of wedges we are using. This type of wedge is called solid wedge. This is called line wedge. Solid wedge is used to indicate the bond projecting out of the plane of paper towards the observer. This is towards the observer. Whereas the dash wedge is represented to indicate the bond projecting out of the plane of paper away from the observer. It is for indicating three-dimensional structure in two-dimensional paper. We are using two types of wedges. One wedge is called solid wedge, another one is called line wedge. Solid wedge is used to indicate the bond projecting out of the plane of paper towards the observer, whereas the line wedge represents the bond which is projecting out of the plane of paper away from the observer.